there is no, so AFM Brown does no active fuel management, which is the V4 4-cylinder mode. This is full V8 all the time. All right, so next we're going to start with KJ. So we've got a completed short block. KJ is going to start with the head assembly. So there are some components that we left off this engine that we mounted right now. We've got a motor mount on it, so we saw the engine mounts. There's a rear seal on the crankshaft. Obviously, this is oil out the back of it. But we have this big piece of equipment that lowers down on those same guide pins and actually installs the rear seal on the crankshaft. We don't have a great way to display that to you, but that would be on the engine. So KJ is going to start with a head gasket, so it's a multi-layer seal head gasket. They are different left-hand and right-hand sides, so you start with the left-hand head. Logan, you want to talk a little bit about the head gasket?
Yeah, so the head gasket, where the builder grabs one, they're looking at it to make sure there's no scratches or coating, because if you have a scratch there, it could be potential repath, and you could have no leak through there, so they look everything over, make sure there's no scratches anywhere in the coated areas, and then also there's some retaining clips, a whole different layers, stuffing gaskets together, making sure those are put together, you know, those loose and stuff being able to move around. So do the checks that you make sure the head gasket is good.
All right, so KJ is going to have to pull the cams out of the left-hand head. Let's hold about the cams back in the right-hand head for a second. Yeah, go ahead and put the cams in the other one. So you're doing it, yeah. You got a sequence just there. No, you're good. So let's talk about head sub-assembly, because in this state isn't how the heads come to us. So we actually build the heads complete ourselves. So they come in as a bare head casting. There's 3 human operation stations on the head sub line and 3 automated stations. So in the first station, the head sub, they take the bare head casting. They're going to put the spark plugs in it, the fuel rail in it, the valve stem seals, and valve springs. We've got camera systems that are, so these engines have a dual valve spring. So there's 2 sets of springs, one inside the other, and release the spark. On the top side of it, there's a blue on one and white on the other to make sure they install them in the correct orientation. So the operator will install all those. There's a camera system above it that will validate that the springs are correct. And there's also different spark plugs, LT6 or LT7. So there's a marking on the tip of the spark plug that the camera system will validate to make sure that the right spark plugs on the engine. And then the fuel rail is scanned via a child, which is married to that cylinder head serial number. It'll come out of that station and go to an automated key-up station. So there's a feeder for the retainers, which is on top of the springs. A robot will pick those up, set it on top. It'll come over and compress it, shoot the valve stem keys over. So there's a vibratory feeder and these really fancy tubes that slides them over there, shoots the keys in, and then releases it back up. And that basically brings the valves and springs all together as a unit. Same thing here, we have a lift assist, so KJ is plenty capable of picking that head up and moving it over here. It weighs about 30 pounds. So next, after the heads are heated up, KJ, hold on 1 second, I'm gonna kind of get us through heads. So once the heads are heated up, it comes into a leak test. So we'll actually actuate the valves. We do a laser inspection, make sure that those keys are installed fully. The camera guy can kind of maybe go on top. So you'll see some springs and finger followers that we're talking about in there. So make sure that's all assembled right. And then we do a leak test on the combustion chamber. So we make sure that there's no debris on the valves. We pressurize the combustion chamber to make sure we don't have a leak valve that gets out. So we'll validate that there's no leaks and that we heat up the valves correctly. It then comes into a station where we'll put it in the camshaft. KJ, you can lift up one of those finger followers on that head. Maybe the front one. Yeah, there you go. So on top of that valve, there's a little latch cap. So what this engine doesn't have lifters, so we have to mechanically set valve latch. And how we do that is we put the cans in, and there's none of those latch caps currently on. We install the cans and fork them down. And we have this really fancy snap gauge, it's called fender that's kind of laying on there, there's a curved surface on it. We'll measure the distance between those on every single location. Then what we'll do is take the cams back out. The head will go into a robot cell. We have 33 different size latch caps of those. So every single one of them is 25 micron different in size. So for people that don't work in microns, a human hair is about 70 to 90 microns. So the difference in each one of those latch caps is a 30 of human hair. And we've got 33 different ones. So we'll install a latch cap on every single valve, some of the robot and the speaker system. It'll then come back into a station, we'll put the cams back in again, and we'll check the valve latch, which is basically the space now between the cam and that finger follower again. But what's cool is at this point, there's a different latch target on every single valve. We did some statistical studies between a head sub and when the head is torqued down. You can never have two perfectly parallel surfaces, so when you torque it down, there will be some distortion between them. So we actually have different theoretical calculations of latch. So when we torque this head down, it comes into a clamp state and the valve latch is exactly where we want it. Alright, so now KJ can pick back up. So head sub's a big process, but it's really cool piece of technology that we go through this process. So cylinder head cam's got to come out so you can get access to the head bolts. So we'll put the head bolts in. Yep. They are like they're sealed, I think. I think they're sealed.
Yeah, they're sealed.
Sealed? Yeah. Seal access. And there's actually a dimension, really hard to read, I have these miles, but you can see the actual size of that latch cap on it. But the engine is, I had a gentleman ask me, the engine is designed to last for life. So the black coating on those finger followers, you can see it, is diamond like carbon. It's on DLC, so it's hard as a diamond, basically. It won't wear. So really, the latch should not adjust over time. So you shouldn't have to worry about it. All right, next, so go ahead and torque those down. So we have another big 10 spindle multi-spindle that'll come over and torque the head down again, so that it's not torquing down or lining up. The whole thing runs down, so you get the gas and all at the same time. Use another torque plus angle critical fastener. All right. So go ahead. So next we're going to put the camshafts in. So we got these fancy holders. There is a different cam you can take and exhaust. So I'm going to set those in there. So one way to tell the exhaust is it's got a spring kind of wound on the front of that front sprocket that you see is actually a phaser. So the bolt that's in the front of it is actually a plunger. You can kind of see that round button right there in the middle of that circle. And there's actuators we'll put on the front. That's what controls your variable valve timing. So the camshaft can actually move inside of that sprocket to adjust cam timing. So next at this point we would have a cam press. Because if you watch this, there's not a perfect way you put the cam in there that the loads are not loaded onto the springs, which will give us an inaccurate torque. So we actually press the camshaft down. So there's a big piece of steel plate we bolt to the head, and a big aluminum fixture that has 4 pushers, and we push the cam all the way down to take all of the spring pressure off. And then we would bring over, we have another big 10 spindle multi-spindle unit that will come torque all those cam caps down simultaneously. So as you can see, we had to turn up the impact down because there's spring tension there that cam doesn't want to sink down. So they'll turn it up and kind of run that thing down to be tight. Yeah.
So basically tomorrow one of these guys is going to take that engine apart.
Yeah.
And put it back into its proper place.
Well, so we'll actually leave it all together, so that we don't lose any parts, and then we get in there. So on Wednesday we came over and tore it all down and set it up. Yep. Yep. Yes, sir. go to the other head.
So these guys basically have to stand the whole shed.
They are, yeah, so throughout the process, it's good, so this looks like we're doing it in a cell. But on the actual build process, there's 17 stations. Go ahead, KJ, I'll kind of talk about you. There's 17 stations in the process that they'll push this car kind of station to station through. We do a good job of, we've got ergo matting and things around the process to try to help it up, but yes, they are standing and building the engine all day long. Good question. Yeah, go ahead. Yeah. Yeah. Anyone have any questions on cylinder heads? Or what's going on? Yes.
Do you guys do all the engine machining here in this plant?
So we don't. So we're full disassembly. Everything comes into us fully machined, ready to assemble. Yep. So we don't have any machining house. Good question. Yes.
Where are the heads cast?
The heads cast, I don't know, but they are machined by a company called Contact, which is in Canada. But I don't know where the casting comes from.
So basically, it's like a dozen plants making parts, and they all stick them in the machine, and then box them, and then rush them to it.
There is, yeah. So yeah, we don't manufacture any of the components that go with it, and they all come into us from multiple different sources, suppliers worldwide.
So that's why the Canadians are upset about that.
All right, so we're gonna put the right-hand cylinder head on it now. The cylinder heads on these engines are really cool. You can see, there you go. Can you show the intake port side for me? So we'll show what's on the camera. But they're like twin barrel, fully CNC machine, and you can see the top of the valves. Like it looks like it's meant to move water air. These cylinder heads truly flow a ton of air. That's why this engine is what it is. Thank you, KJ. So those tubes you'll see up at the top, the spark plugs are down inside there. So spark plugs are actually down in the head. And one of the cool things about this design of the cylinder head is typically your fuel rails are up on the top of the valley, and the injectors go through the top. For these, the injectors are actually on the bottom. A lot of that was so that they could maximize that intake port design to really just move air. So as that torque goes down, so the exhaust outlets are partially CNC. So on the outside there's a light CNC kind of just smooth transition to the exhaust manifold that I'll put in later. To give you a sense of where we'll be at in the build process, this is basically the fifth station of 17. To give you kind of an idea of where we're at in the process. But the front portion of the line is really where a lot of the content of the engine really is.
We're less than a third of the way through.
What's that? Yep. Yep, about a third of the way through.
It did look like it was going fast.
What's that?
It looked like it was going very fast.
Yeah, yeah, and like I said, there's a ton more of the actual process that we're not doing in the actual build of inspection and oiling and proper care when they're doing this. So this is an expedited process of the engine build process. One cool thing about that camshaft is it's an assembled cam, so that the shaft of it is actually all hollow. So it's not a billet piece of metal that's turned out from camshaft. The lobes are actually machined separately and then pressed onto that shaft, hollow tube shaft, and oriented in the correct position. Helps with reducing mass on the engine. So we'll zip these down. One of the cool things, so these caps, every cap is numbered, so you can't interchange them. They are airproof, they have to go back on the spot that they came from. There's also an orientation on it, and if you can see on there, there's rockets that rocket towards the front of the engine to allow the operator to know which way to orient it. And that heads-up assembly process that I talked about, that's another one of those things that we airproof, that there's a camera system that will check it to make sure that we finalize that head portion of the cage that was assembled properly. Yes.
In regards to the air filter, I know you've got cameras and whatnot. You have another sort of check that other operators might.
Yeah, so, Dale's one of the doors, so he's, asking some of the tough questions in the crowd. So, one of the things that we'll do is, there are some things that we don't have air moving forward. And as you're doing this every day, we're all humans, ready to make mistakes. So we'll do a process called a bloody check, which will have a secondary engine builder come, inspect and make sure that they did it properly on some things that we can't air proof. So think of, CPA clips on harnesses that are engaged. We actually have someone just double check us on clip wrenches and rod bolts to make sure that our tooling didn't mess up. We do a lot of secondary checks to make sure that the engine will work with quality. Thank you. Yeah, you want to do a buddy? All right, so next, KJ is going to come around. So at this point, we would do the final latch check. So once the cams are fully installed, we've got another one of those Marpos gauges that would go to every single position and validate that the latch is in spec in the Foley plant as we're going to ship it out of state. All right, so KJ is going to bring a chair around here. And then, so pinch bolt. So there's a couple of small little bolts that will pinch the outer gaskets that the head bolts don't fly properly too. So he's going to put those couple of pinch bolts in. Yeah, so we got a little process, but what he's doing is that camshaft is actually blocking that bolt from being able to be accessed, so he's gonna run it down there. Yeah, good thing we're not firing this end up. Yeah, so what, obviously, mistakes can happen. We got a little lot of sequence that we're talking, and I've got KJ way out of the normal rhythm. But in our process, that smart bench, it basically won't allow you to do something out of order. So it wouldn't allow him to torque those cams down if that pinch bolt wasn't shot. So it's part of that process where we can't, mess up the process. All right, KJ's going to come around the front of the engine and do timing. So the timing system is really pretty cool on the front of this engine. So he's going to bring this kit over. So it comes to us kitted. When he brings it over, you'll see some color blinks on the chain. Yeah, you can move that. So you'll see a bunch of sprockets, tensioners, chains. At this point, this engine's already marked, but there's dimples on all the sprockets and on those camshafts that have a mark where we need to align up the color links to. So KJ's going to get a ratchet, he's going to set the cams into a cam lock position. And basically what that does is the fixture that he's going to put on will lock the camshafts into the position where all our timing locks will line up, our timing marks will line up. So we're going to put those on. It holds those camshafts so we can orient and move the slack of the chain so that he can get all the chains on. So what KJ just did there, before he started rotating that intake cam, it is an interference engine. So if you had an exhaust valve on full lift and open, and you open the intake valve, they will collide into each other. So he's making sure before he starts rotating the camshafts around that none of the cams are loaded. So you'll hear it kind of snap over. You won't have to do this time. I'll have them kind of rotate it over so you kind of hear it load and snap on the other head. see the intake, we've got colored blue, there's a blue line there, kind of vertical, and on the exhaust, there's a red line on both the cams. So, okay, just kind of rotate the cam around a couple times. So you'll kind of hear the blows will open and then close. Like that, there you go. You just go back where you want it. So you want to make sure that it's in one of those snapped, relaxed states. You're going to start rotating it. Okay, is it running at 3 o'clock anyway? Yeah, perfect. So, go ahead and start doing time, and I'll kind of talk about it as we go. So, what accident is we have another piece of air equipment. So that keyway that's on the crankshaft, it has to be at 3 o'clock for timing to be done. So we're a little out of process because we don't have the, it's not 3? We got the tools around. So, yeah. Yeah. So, a little out of process. So our torque turn machine I talked about earlier, will actually air-proof this. We don't touch the crankshaft at the torque turn only. And there's a prop switch that'll pick up on that keyway to make sure that in the process the crank is already set in the right position so the builder doesn't have to mess with it. So Gage is going to spin that around for us to get where it needs to. Alright, there we go. So what he's going to put on first is the inner drop shaft sprocket. So that sprocket's actually got 3 sprockets on it. So the big one in the back is actually going to drive the inner drop shaft that drives the fuel pump. So if you ignore the front 2 sprockets on the front, it kind of looks like a normal small block timing, except that I have a crank sprocket and a cam sprocket. And there's marks that he's going to line up to make sure. So that inner drive shaft at the top has a dowel on it. That dowel is going to engage in the back of that sprocket. Cage knows right where to put it, and then it'll torque down. So he's going to adjust that drive shaft to air. So you'll see there's a pink mark on the top that's lined up with a tooth, and then there's a yellow sprocket mark on the bottom that's lined up with a crank sprocket. And you want to talk about Logan? We're talking about it. Yeah, all right. He does Logan hard quality questions. All right, so as he's going through time, so the next thing he's going to do is put the tension on, which puts tension on the chain, and then he's going to start working on the front of that crank sprocket, which is on the bottom side. There's a different style looking gear on the front of it. That's going to go over to the oil pump shaft that he'll put on here now. So the oil pump output shaft is splined. So there's a little engagement tool that he uses to get that sprocket to go on there just right. And then he'll put the chains on it and then release the pin for tension. spin that sprocket, and it'll get the slide, onto the spline of that wall bump. You're gonna pull the pins to put tension on all the tensioners, which will put the tension on those chains. Alright, so this is where it's one of the, KJ will make it look pretty easy, but I tell you, I've done it myself unless you've done it a bunch of times a day. To put these, so now we're gonna do the cam timing. So, the cam, it's got two chains, so one on the right hand side, one on the left hand side. There's two, smaller sprockets on that top sprocket that he's gonna put those chains on. So KJ knows pretty much exactly where he wants to put that crankshaft so he can get slack in the chain and have all the timing marks on it. And kind of work that chain around to get the tensioners in, and get it done really quickly. This is one of the processes that I would say is the newer engine builders come in that takes the most reps and time to get to where it looks like it's muscle memory, as he's putting it together. So he's putting some chain guides on there, so the chain will, ride against as it's going. So he's gonna move some tension up there so you can move the slack towards the bottom to go to this tensioner. So those tensioners, the ones you're applying now is fed with oil, so it'll hydraulically adjust that tensioner around that temperature armor. So the tensioner you just installed will push pressure up on that nylon guide and keep tension on that chain all the time. Next, he's going to move over to the other side. So you'll see those orange colored links at the top. He's aligning to the tooth that he has marked as the dimple line. And then on the bottom side, he's making sure that pink link is on the link with the dimple on that lower sprocket.
Not my J1 small one.
No. Alright, so timing is all done. It's pretty easy to see the front of the engine with all the chains out. We'll pull all those timing pins
cameras on this board?
Any cameras?
Yeah.
Nope, so this is one of those ones where we do a buddy check, but also they've got a set of mirrors and they're inspecting. One thing we're driving is, this is something that can easily be out of place. I'll talk about how effective it was in a little bit, but, it is a challenging part of the engineering process. Yes?
What was the, service, material that like the chain guide, chain light?
It's like a Delrin nylon style material. I don't know the exact material properties, but that's the best I can equate it to. All right. So this is another point where there's sealing surfaces that we have to seal it. So I'll let Logan talk a little bit. Do you want to talk about front cover gaskets and RTV?
Yeah, so the front cover, you have here in the standard, see the station gets set up, but there's a gasket along the top and along the bottom, along the edge of the surface. And there's two smaller ones for the water ports. And then there's also a couple ports on there that put the same RTV that we use on the lower crankcase, just to bridge those gaps where it meets up between the head, block, and front cover.
Yep. Alright, so Kate is going to bring over that front cover. So it's another cool piece of equipment. So on this front cover, it's got an integrated, the water pump's integrated into it, so there's a couple of water pump seal gaskets, there's coolant that'll flow through it as you kind of see the passages on it. And it's got 26 bolts on it, and it's a mandatory torque sequence. So you gotta be able to do 26 bolts in the right order. So this is another cool piece of that tool tracking system that we have. It's called Spot Point. So in this process, you would put a little transmitter on its engine. There's a camera system up above, and there's a transmitter on the torque tool. You can go ahead and start doing it.